This is my video number 18. I'll talk on the concept of supremum and infimum. Okay, so what is supremum and what is supremum? So let's suppose that we have a set of real numbers, okay, and if m is the upper bound, if m is the upper bound of a, then all x, which is that number in a, must less than or equal to m. Okay, for all a, of course, for all x in a. So what does this mean? So if you consider, let's say we have a set of real numbers. Okay, so if we arrange that set of real numbers, let's say we have that kind of things. Okay, so in this case, this is our m, the upper bound. Okay, so this we call it as a upper bound. Now if you have, among all this, we have another m, for example, let's say we have m1, okay, which is also upper bound, but less than m, because the upper bound, if you consider here, this is also upper bound. If you consider here, this is upper bound. Among those upper bound, we have the smallest upper bound between them, which is very close to the biggest element of the set. Okay, so we may call this, in this case, m1 as a least upper bound. So if m1 is also an upper bound, is also the upper bound, of a, so we call it, in this case, as a supremum. If m1 is also upper bound of a, in such a way that m1 is less than m, m1 is less than m, or I can say m less than or equal to, then we say this m as a supremum of, so we say m1 is the supremum of a. Okay, so I can write this m1 as a, in terms of notation, we can write this as a m is a supremum of a. So in this case, the supremum, in short, I can write supremum is the least upper bound. Least upper bound. Okay, so in a similar manner, we can define the concept of infimum. For the concept of infimum, if we have let's say we have this kind of sequence. Okay, here let's we denote this as, or here let's we denote this as m, small m. Then we see m is a lower bound of a. If m is less than or equal to x, m less than or equal to x you have here, it is x, element of the set, then for all x in A. So if you have another element, let's call that small m1. Yeah, let's say the m1. If we have m1 is greater than or equal to m, so this m1, okay, we call it as a greatest lower bound. Greatest lower bound, or we call it as a infimum. Infimum of A. In terms of notation, we have m prime is m1, infimum of A. So I have introduced here also infimum of A is basically the greatest lower bound, supremum is the least upper bound. Yeah, infimum is the greatest lower bound, infimum is the least upper bound. I can say LUB, least upper bound. This is a GLB, greatest lower bound. So that means infimum. So I introduced to you the concept of supremum, the concept of infimum. So I would like to give some example. If this not is true, this is the true statement. If a set A has an upper bound, then A must has a least upper bound, least upper bound, or supremum. So as well as if A has a lower bound, I can say if A has a lower bound, then A must has a greatest lower bound. Greatest lower bound. Now let's see example. Okay, let's see example. Simple example. Let's say if I have A is the set of this interval 0, 1. Set of interval 0, 1. So you can put this like this. This is 0, this is 1, including that. Okay. So the biggest because the element of A here is between 0 and 1. So you can choose any values there as an element of A in between those things. But you cannot go beyond than 1. You cannot go lesser than 0. So in this case, I can say supremum of A is 1 because this is the biggest upper bound is A. Okay. So for the biggest upper bound, if I choose here 1.1, this is also bound for upper bound for A. But we have the smallest or the least upper bound of A, which is 1. Okay. And infimum of A, which is the greatest upper bound, greatest lower bound. The greatest lower bound is here. This is lower bound. So greatest lower bound, you cannot go beyond that. So this is 0. Okay. So this is first example. Second example, let's say if you consider A in this half open interval. Okay. So in this case, supremum of A is still 1. Infimum of A is 0. But what's the difference between these two? In this case, the supremum of A and infimum of A contains in A. Yeah, supremum of A and infimum of A both contain A, because you can see 0 and 1 is in A. But in this case, supremum of A in A, but infimum of A is not in A. So in other words, I can say that the supremum of any set of numbers, or infimum of any set of numbers, doesn't mean in the set itself. It could be outside of the set. The example is this. Okay, so if I have in form of a sequence, let's say I have our A is given as this set in form of sequence 1, 1 over 2, 1 over 3, and so on, 1 over n, and so on. So it is obvious in this case, that this sequence goes to 0. If you choose n big enough, this sequence goes to 0, but not quite 0, right? Not quite 0. So if you plot that, so we have 1, when n is 1 here, then half, then 1/3, and then so on. So you can see from this sketch or this plot that this is our upper bound. This is our lower bound. Yeah, lower bound. So the upper bound, or the least upper bound, supremum of A is 1, and infimum of A is 0 for this case. So of course in this case 1 is in A and 0 is not in A. Alright, another example, if you want to consider, number 4, if you have, let's say, this kind of sequence, sines n pi over 2, that sequence, right? N from 1 to infinity. Okay, maximum for sine is 1. Alright, so you can put supremum of A is 1, and minimum for this is -1, because what we call this, the element is from 1, -1, 1, -1, 1, -1, 1, -1, oscillate. Alright, so infimum of A is -1 as a greatest lower bound. Alright, and let's see other example. No, let's go to the limit of the superior. Now we have a superior, we have we have a supremum, we have infimum. Now we are going to the limit of the supremum and limit of the infimum. Okay. Now let's say we have I define mn as a supremum. You know what I mean by supremum? Of un plus 1, un plus 2, and so on. This is supremum of UK. This is UK, supremum of UK for k greater than or equal to n. So that's how do you write? And we define mn, small n, mn, as the infimum of un plus 1, un plus 2, and so on, which is infimum of UK for k greater than 1, greater than n, greater than or equal to n. So for these two cases, okay, for these two cases, so if a sequence un has a supremum, it means bounded, and is increased, So it has so the sequence is increasing and decreasing. So we have a sequence is bounded and decreasing, as well as this one for the sequence is bounded and decreasing. If you consider those things, then the limit exists. Yeah, then the limit exists. So if the sequence of supremum, because from here you can have, for example, you can find M1 is supremum of U1, U2, and so on. M2, you have supremum of U2, and so on. And we can have M3, M4, and so on. So this collection of supremum, we can make it as a sequence. Okay? So if M is bounded and decreasing, yeah, if Mn and this small m n bounded and decreasing, what does it mean? So it means it has a limit. Or they have a limit. They have a limit. So which means the limit exists. So I can write this, or we can find the limit of Mn, that's capital Mn, and goes to infinity. Okay, and Mn by definition is the supremum of that. So I can write this as a limit of n goes to infinity, supremum of uk. So now we come to the concept of limit for the supremum. So we can do the same for the infimum. If Mn is the sequence of if Mn bounded and increasing, which means the limit exists. The limit exists. So therefore, if the limit exists, we can write the limit of Mn, n goes to infinity. This is the limit of infimum of uk for n goes to infinity. So now I've introduced to the concept of supremum, introduced the concept of infimum, limit of infimum, and limit of the supremum. So let's see a couple of examples. How to find the limit of the lim sub and lim inf for a given sequence. Some example. Okay, determine the lim sub and lim infimum of the following sequence. Okay, let's say I have this sequence 1 over n. If you list this, we have 1, 1 over 2, 1 over 3, and so on. Okay, now in order to find this, we suppose or we define Mn, capital M, as a supremum of Un, Un plus 1, Un plus 2, and so on. Okay, if you substitute this Un plus 1, Un plus 2 into that, so what we have, this is for M1, you can put M1, this is supremum of Un, which is U1. Okay, U1 is 1, U2 is 1 over 2, 1 over 3, and so on, which give you supremum, is the biggest one, so 1. Yeah, we have a greatest upper bound, which is 1. So you choose M2 this is supremum of, look at the definition, our definition here, but n begin with 2. So we need u2, u3, u4, and so on. So u2, our u2 is half, 1 over 3, 1 over 4, and so on. So the biggest among this is half. So this is half. Okay, so you can proceed this until you can find a general form of Mn. So from here you can see if you choose M3, this will give you 1 over 3. So you can see the pattern there. Once you obtain the pattern, you can form the sequence of Mn, which is given as, this is 1 over 2, 1 over 3, and so on up to 1 over n. So this is 1 over n. Now, if we take the limit of this, we take a limit of n goes to infinity of mn, which is limit n goes to infinity supremum of that sequence. Let's call that sequence un. So this is the limit of n goes to infinity, that sequence given by 1 over n, that give you 0. I hope you can understand those. So therefore the lim sub for un is 0. Okay. What about in lim infimum? Yeah, lim inf. So we define, for lim infimum, we define small m n as a infimum of un plus 1, un plus 2, and so on. Okay, we define that. Then from there, we can have m1 is infimum of your u1 here is 1 half and so on. So u1, u2, u3, so we have 1 half, 1/3, and so on. Okay. Infimum is the greatest lower bound. So if you can see this goes to 0, right? It goes to 0, but not quite 0, but it goes to 0. So the infimum of that sequence is 0. Then m2, which is the infimum of u2 is 1 over 2, 1 over 3, and so on. This is also 0. If you choose m3, you can also have 0, and up to mn you go to 0. So therefore you can find the limit. Okay, limit n goes to infinity, mn, which is limit n goes to infinity, infimum of un, that's equal to limit of n equal to 0, infinity. So infimum of un, we got 0, 0, so that gives you 0. So in this case, the lim sub and lim inf both are equal to 0. Okay? I hope you can understand the concept of this, and then I hope you can understand how to find, how to find the lim sub and lim inf if you're given a particular sequence. I have a couple more examples here. I think I'll do one more. I'll do one more example. Okay, so let's consider this sequence. Let's say our sequence -1 to the n over sub n, that sequence. So if we list this, so this we have 1 -1, 1 over sub 2, -1 over sub 3, 1 over sub 4, and so on. Okay. Then we need to find this lim sub and lim inf. So to find lim sub of un, we want to find this. We define, always begin with this. We define what is our Mn? Mn is a supremum of un plus 1 and so on, un plus 2 and so on. Then we find what is Mn. What is Mn? Mn is supremum of u1, u2 and so on. So u1 is, we have minus 1, 1 over sub 2, minus 1 over sub 3 and so on. And you can see, and supremum is the least upper bound. So in this case, upper bound, which is 1 over sub 2. So that's our upper bound. Okay. Then if you find M2, our M2 supremum, we have begin with 1 over sub 2. So 1 over sub 2, negative 1 over sub 3, and so on, which give us 1 over sub 2. If you find M3 is supremum of, from the third terms, minus 1 over sub 3, minus 1 over sub 4, 1 over sub 4, 1 minus 1 over sub 5, 1 over 6, and so on. So supremum of this is 1 over sub 4. Okay, choose the biggest one among them, 1 over sub 4. Okay, and from there, you can see this is 1 over sub 2, this is 1 over sub 2, 1 over sub 4, so you should expect this 1 over sub 4. 1 over sub 4. Basically, you can check from there. For M4, our list or our sequence begin with 1 over sub 4, then you can have the rest of it. Okay, and from there, we have, this is 1 over M1, M2, M3, M4. Then next you can have 1 over, next M5 is 1 over sub 6, M6 is 1 over sub 6. Then how can you generalize this? How can you generalize this? So look carefully. How can we generalize this? Generalization is important. So if you look at here, for m equal to 2, for n, small n, equal to 1, 3, you see, it's changed from 1 over sub 2, 1 over sub 4, 1 over sub 6. You can see here, that. And then you should expect m7, 1 over sub, what? 8. Alright, so in this case, we have the odd number here, odd number. So that gives you m 2n plus 1 minus 1, because it's beginning with n, so 2n minus 1. This is, we have 2, 4, 6, 8. That gives you odd number, set of set of even number. So that's you have 2 over n. And then for 2, 4, 6, and next 8. So we have what? We have 2, 4, 6, and 8, and so on. So for m, 2n is 1 over sub 2n. Okay, so if you take the limit of this, if you take the limit n goes to infinity, since they are same, so you can pick, this is, you can, limit n goes to infinity of m to n minus 1 is just the same as limit n goes to infinity m of n. This is basically limit n goes to infinity sub of un, which is the one that we're looking for. So this is equal to limit n goes to infinity, our supremum given as 1 over sub 2n, that gives you 0. Similarly, we can find the lim infimum. Okay, what you need to do, just define what is lim infimum. For lim infimum, okay, we define mn is as a infimum of un plus 1 and so on. Then we find what is m1 from infimum of minus 1 over set 2 minus 1 over set 2 minus 1 over set 3 and so on. So the greatest lower bound in this case is minus 1, which is minus 1. Okay, for m2, infimum of 1 over set 2 minus 1 over set 3 1 over set 4 minus 1 over set 5 and so on. That gives you 1 over minus 1 over set 3. So from there, you can find m3 minus 1 over set 3. You can find m4 as a minus 1 over set 5. You can find m5, which is minus 1 over set 5. So we have m1, m2, m3. So look at m1, m3, m4. Okay, m1, m3, m4. So m 2n 2n plus 1, which is 3, 2n plus 1, because this one is I would say this is outliers because it's not in that pattern. So we try to exclude those parts. So looking for the one that we can recognize the pattern. So begin with m3, so that and that. So next m7 we should expect 1 over set 7 minus. So in this case we can have m 2n plus 1. This is minus of 1 over set of 2n plus 1. And as well as for m odd even, that we have minus 1 over set 2n plus 1. So therefore we can find the lim infimum of un, which is lim of small mn, which is the limit of n goes to infinity negative 1 over set 2n plus 1. Right? So you take the limit of this. You should know how to take the limit of that equal to 0. Okay, so I have a couple of properties regarding the lim sub and lim inf, but I think I just keep all those things. Yeah, we have a definition of the limit. So what is definition? Lim sub un is equal to L if given any epsilon positive, we can find n positive such that the difference between supremum of uk for k greater than n minus L less than epsilon for all n greater than n. So similar explanation to the previous definition for limit, where we have epsilon. You know what epsilon is. We have capital N. You know what capital N is. All right, and you know what we mean by there exists n positive. So that's a similar explanation with the limit case. Yeah. So I think I stop there for the limit here. So for the next video, I just jump into the next chapter, the series. Right, so I stop here. Thank you.